Hey guys, I just want to show you a project I've been working on in Minecraft. It's up here, or at least a good view of it is. This is a arithmetic logic unit. And an ALU is found in every processor because it does math. And math is important. It is 16 bits, and somewhat slow and big and unwieldy, but it's implemented in a video game. What do you want? I have it set up hopefully so that when I add registers and RAM, probably not very much RAM, and program counter, it'll be a legit computer. And not just any legit computer, and I'll get to that in a second. I'm gonna have it add 1 plus 1. Well, how about 2 plus 2? Or 2 plus 1. How exciting, right? But that up there was one of the inputs. Here's the other. I'm going to do 2 plus 1. It's going to be crazy. And these are the control bits. The control bits will let you do various things to the inputs and output that to something else. So I can set some to 0 so I can get the other one out and send that somewhere else, or negate them, or bitwise AND, or plus. These are the only two real mathematical operations my ALU can do. It can add and it can AND, but that's enough. So I'm going to turn that on so it adds it, and we look over here, and this is reversed because there's a huge bus taking all the values from the end of the ALU all the way back over here. So when it comes around back, it gets pointed this way. So we added 2 plus 1, we get 3, which is 1 1 in binary. There it is. And what else? Oh yeah, this is not just any 16-bit ALU. It is a 16-bit ALU which, once the other bits of a computer are stuck onto it, will have like actual support, because there's this very cool book called The Elements of Computing Systems that I read about a year ago, and it has like an example computing platform which is used as a educational tool to let you learn how computers work from the bottom up. And the reason this is relevant is it has a very simple but robust instruction set and machine code and just kind of the specs of the machine. And they're simple enough that I implemented its ALU here. This is it's called the Hack platform, and this is a Hack Computers ALU. So when I connect all the rest of the parts of the computer to this, I will have an assembler and a compiler ready that can read actual like programming languages and translate them into machine code that can run on this. It can run on a Minecraft computer. So I don't know if that's been done before. I don't know if there's been one of these video game computers that has a compiler that works for it. But once this is done, this will have one, which will be awesome. But don't expect it to run very fast at all. I'll go back to the output and show you how slow it is by demonstrating the wonders of ripple carry adding. And while I go back, I'll point out all the little parts of it, because those are cool. The control bits run out to muxers. This is a muxer right here, and this just selects out of all of the various operations it can do. These muxers select from them, or choose out of all of the operations it does, which one's the output. It's doing all the operations all at once. So all the various things it can do, bitwise and adding, negating, all that. It does it all. It does it to all of the numbers all at once. But what it outputs is based on the muxes. So it always has all those numbers ready. The muxes tells it which one to spit out. The adders are right here, from right there to right here, and it goes all the way down 16 bits. So like here's one, here's another adder, and this is probably the slowest part of the machine right now, because it's using something called ripple carry adding, which means it adds 2 bits and then sends the carry down, and adds 2 bits and sends the carry down. So it goes from one to the other to the other to the other. You listening, Pig? It goes from one to the other to the other to the other, all the way down until it gets here, which takes a long time. It's not doing them all at once, and an optimized way is to do batches of them at once, the carry operations, but which would make this much faster. Instead, it kind of has this cascading effect, which takes a long time when you're using big numbers, and so it, based on how big the number you're adding is, there's a longer and longer wait to see the sum. I'll show you that now. By adding something huge. So, you see, by the time I've gotten down here, it's already done it. But I'll negate one of them, and you can watch it ripple down. See, there it goes. So the bigger the number, the more protracted your wait for an answer is. But, you know, I'm sure this thing is, you know, not exactly very well optimized. In fact, I'm sure it's just kind of a cluster right now of just bad design practice that I could clean up later. But it's done, and it works. And like I said, I'm very excited about it being an actual platform with actual compilable code that can run on it. That's going to be very cool. So this is probably a big chunk of the work that's done, and everything else is going to be very tedious. The RAM is going to be very tedious. Clearly buses are going to be very hard. That is a 16-bit wide bus right there. I'm going to have to figure out how to get everything in line and wrap around as few times as possible, because a lot of the weight also is this huge bus, because the repeaters add lots of time. But as I build this thing, I'm going to figure out more and more ways to speed it up, and maybe by the time I have all the parts in place, it'll be more than usable, and some of that compilable code you'll actually want to click start and wait for it to finish, instead of walking away from Minecraft and checking the answer, you know, an hour from now. So we'll see how the instruction speed goes once I get there, but just the fact that this works is very cool, and the fact that it's going to be something awesome in the near future is something to look forward to. I hope you guys check in later to see this once I have a few other finished chunks done. Thanks for watching.